Alright guys, so this video is going to be on GCF factoring. We should always check for a GCF first, no matter what kind of problem it might look like, because remember we have those two-step problems. For the numbers, for the coefficients, we always want to find the biggest number that divides nicely into all of those terms. And then for our exponents, it's just whichever one has the smallest, because that's what we can say that all of those terms have. So in this first example, we have 45 and 15. So the biggest number that would divide nicely into both of those is 15. And since we have x squared and x, again, we use the smaller exponent of the two. So we can say that both of them have one x. We can't say that both of them have two. So basically all of my terms get divided by that GCF. And we're going to put what we would have remaining after we divide that out. So 45x squared divided by 15x would be 3x. And then 15x divided by 15x, I do need to put that plus 1. A lot of y'all were making that mistake that you didn't want to have that 1 there. But just 15x times 3x, is not going to become that original problem again when you multiply it back out. So that would be our final answer there. Second one, we have 3 terms. This one, a lot of you might think it looks like a SMAG problem, but we can actually do a GCF of 3, because 3 goes nicely into all 3 of my terms. I do not have any variables here in common, so the only GCF we are going to have would be 3. So the whole polynomial gets divided by 3, and we're going to put in what we have left. So when we divide 3x squared by 3, we're going to be left with x squared. 21x divided by 3 would be 7x, and then 30 divided by 3 would be 10. And then at this point, we would need to consider, is there anything more we can do with that? That might be like a two-step problem. Okay, the last one here, we have 2 terms. So between 4 and 2, biggest number that divides nicely is 2. We have x squared and x cubed, so that means that we would have 2 x's that we can say they both have. And if I have y squared and y to the 4th, they both have 2 y's. So again, we use the smaller exponent for all of our variables. So the whole thing gets divided by that GCF. We're going to write what we have left. So when I divide my first 2 terms here, we're going to be left with 2. And when I divide these terms here, we're going to be left with xy squared. And we would be done. So that is GCF factoring.